Hello, I am Lester. I am presenting my final handpiece design that will help a person with zero hand function to change welding rods. Just a bit of recap. This handpiece is designed for Peter, a person with C4 to C5 quadriplegia. He spends a lot of time in his gantry welding old scraps of metal into beautiful artworks. Here are a few of the inspiring examples. Currently, Peter uses a clamp electrode attached to a PVC pipe. It works fine for him, but with the inspiring and beautiful artworks he creates, he certainly deserves a safer and more efficient handpiece. Previously, I have presented this design. This expanded view shows the main cavity in the middle, where the hand is inserted. It is surrounded by a layer of materials and the outer metal surface. Pinhole jacks with different diameters are installed for easy fixing and unfixing of different welding rods. This is the interior view of the handpiece, showing the location of the hand inside. So this is the main feedback I received from Peter. He asked for more details on the clamping mechanism of the handpiece. I appreciate the feedback he gave me as it was used to improve the design and making sure that his main concern is incorporated into the final design. So this is the final design. It is still composed of two main parts, the sleeve and the welder part. This time I have put more details on the welder part. The welder part is installed with pinhole jacks of different diameters for fixing and unfixing of welding rods. This will be explained in detail in the following slides. This sketch shows the clamp details. Two clamps are in the picture. One is for 3.2 millimeters and the other is for 2.5 millimeters. These are the two welding rod sizes that Peter usually uses. These clamps are located in the welder part of the handpiece, which is also attached to the sleeve part. The picture in the top right shows the jack details. The welding rod sits in between the jack body, where it is connected to the power source at the end of the jack body. An anchor that can move at an angle enables Peter to move the welding rods at different directions. This is important so that his body and hand movements during welding are minimized. The picture in the bottom shows the bolt details, which is also important to keep the welder part of the handpiece attached to the sleeve and immobilized. This sketch shows the locations of the three different jacks. One for 2.5, the second one is for 3.2, and at the bottom is a jack for 4 millimeter welding rod. Although he only uses 2.5 and 3.2 millimeters, the third jack is an extra provision in case he needed a bigger welding rod. It also shows the location of the power source line, thermal sensor, and the bolts connecting the sleeve and the welder part. As for the manufacturing plan, the layers of the sleeve are designed for comfort so you can work for longer durations. So these are the layers of the sleeve. The innermost layer is made of textile. It's followed by a polycarbonate layer which provides the main structure of the handpiece. The polycarbonate layer is covered by an insulation material to keep the heat away from his hand. Then finally, a metal sheet to keep the insulation material in place. As for the welder part of the handpiece, this can be fabricated using the least electrically conductive metals. Titanium and aluminum are poor conductors. However, titanium is relatively expensive, making aluminum the preferred choice. Also, Peter aims to have the handpiece to be lightweight, making aluminum the sensible choice. The anchors in each of the jack are installed with springs, and they are fitted between the anchor and the jack body. This is to give the anchors movement during welding. Further feedback from Peter on the design is much appreciated and will be noted. And he will also be asked for material preferences for the manufacture of the handpiece. That's my final design. Thank you.